I've already I solved this, but I was going through it. I just hit some calculator buttons, so it didn't work out. But as you saw so we have 14. So basically in this problem, we have 14 meters, 21 south of west. All right. And we've got 21 degrees, and then we've got 21 meters, 43 degrees west of north. All right, so this is just a little vector problem thing. All right, so let's start with our first one. This will not be drawn to scale by any, like I did on the last one graphically, but he's going south, so that means, let me draw this bigger. So if it says south of west, that means we go south, our angle goes south of west. So we start on the west thing, go south. So we go like this, okay? All right, and that's 14 meters. Now, and this is at 21 degrees. Now then we start here, let's draw this bigger. Now what they want us to do is they want us to go west of north. Okay, so west means we rotate this way, rotate towards the west, 43 degrees. So we go 43 here, like this. So this is off the perpendicular here. And this goes 21, which is bigger than this one a little bit. And then we want the overall, then we're going to get this angle right here. All right, I don't like doing it this way, so I want it because, so basically all you got to do is you got to find your, now notice this guy has an x component for the 14. This is for vector 1. He's got an x component here and a y component here, right? So let's just write down our components. Let's just get the laundry list going. X component, y component. The x component, this one would be negative 14 times the cosine of 21. And it'd be negative 14 sine of 21. Those are its two components. And then the next one, since I'm going to measure, and I got lucky, I think, when I did it graphically, because 47 and 43 are real close to 45, and 40, and so 4 degrees isn't going to cause, I allowed for the error in the problem. They had, I built in a lot of error for this problem. So I've got another negative x, negative 21 in cosine of 47, or you could have used the sine of 43 if you wanted to. The cosine of 47 and the sine of 43 works the same way because it's also going, if we draw all the way up here, it's this rectangle right here. So both of either one of these vectors could work, where this would be the opposite over the opposite leg, whereas we're using the adjacent leg here. And then I'll use the sine for this one. So, but that one's positive, so that's 21 sine of 43. You add these guys up. This one comes up to be negative, when you add these guys up, this comes up to be negative 27.3 meters in the x direction. And this comes out to be like 10.3 meters in the y direction. And you got to be careful with your calculator. So my calculator, because watch what happens. If I go negative 27.3 squared. Now what my calculator does is it's going to take the exponent first and then multiply by the negative. So you got to be careful. So I got to do this. I got to go parentheses, negative 27.3, close parentheses, squared. So you got to know your PEMDAS when you're using the calculator. Plus, this one's positive, so I won't worry about it. Squared, boom. Now I'll take the square root of that. And I wind up with 29.2. Okay? So the resultant vector is equal to 29.2 meters. And the angle then, what's the angle? And how are they asking for the angle too? That's what I want to know. How are they asking for the angle here? Part B. This is what is the angle of the compass direction of a line connecting your starting point to your final position measured north of west? All right, so we're going to be facing west, and we're going to measure that angle going up north. And that is this one right here. That's this angle. What is this angle? Well, here are my two, so I'm going to take theta equals the inverse tangent, and I'm going to make it all positive, of 10.3 over 27.3. Because I already know the direction is north of west. 20.67 degrees. I'm going to put that in. I'm pretty confident that's going to get me in the hunt. We'll see. I hope so. Yeah. Theirs was 0.68. I got 20.67. That's the way you do that.